polynomials, or who knows, if they change the unit numbering again. It is the unit on polynomials. This first objective is, can you identify and classify polynomials? This first question asks you to determine if each of the following is or is not a polynomial, and if not, why not? Okay, this first one up here, 7x to the 8th plus 2x to the negative 1 plus 4. Realize that this is the same thing as 7x to the 8th plus 2 over x plus 4. This is a problem. There can't be any of those pesky negative exponents. So the answer here is no. And if you have a pen or pencil that can write better, can't have negative exponents. Okay, next one up. This one simplifies to 2x minus 3 plus 5 over x. This is a problem. This again is no. If you were to graph it, you would find that it has a break, okay, or it has a sharp corner. In this case, it has a break. It's got an asymptote. This next one is yes. This is a polynomial. This is called a cubic. Finally, over here, this one, the square root of x to the 5th plus 9x plus 4, this is a no. Okay, this has a rational exponent, meaning this whole thing is to the 1/2 power. Okay, and no, you cannot simplify it at all. Now, circle all the quartic. This is 4th degree polynomials. I have an x to the 4th is the largest, so that is x cubic, no. To the 6th, no. Cube, no. 4, 3, 1, yes. 4 is the highest. Remember, I got to make sure 4 is the highest. If I had a 4 and then a 7, no, it wouldn't be a quartic. Here, no. Here, this is a degree of 2, so it's a quadratic. This is a cubic. Oh, but there, this guy right here, so this is a quartic. So I would need to circle all 3 of those. Remember that we have constants, then we have linears, then we have quadratic, cubic, quartic, quintic, and then we just have 6th degree, 7th degree, 8th degree. We really just don't memorize all those other names. Now, naming each polynomial by degree and by number of terms. Degree is by the largest degree. The largest degree here is 3. So this is a cubic. There are 2 terms, so this is a binomial. Remember, 1 term is monomial, 2 is binomial, 3 is trinomial. Anything more than that is just a polynomial with so many terms. This next one, I have a 5th degree. So this is a quintic. And there's 1, 2, 3 terms. So this is a trinomial. The next one, the highest degree is 1. So that is linear. We have 1, 2 terms. That makes it a binomial. This last one is 16. And you can think about it as that's x to the 0 power. This means it's constant because x to the 0 is 1. 1 times anything is just itself, so it's always 16. There's only 1 term, so this is called a monomial. Name them by degree and number of terms. Pretty straightforward. That's objective 1. We're also going to put objective 2 in the same video. Objective 2 is to write a polynomial given the solutions. Well, to do that, make sure that you don't do more than you have to. In other words, pay attention to which form. Write a polynomial in standard form. Okay, this means that I have x equals -1, x equals 3, x equals 7. I need to get these equal to 0. So it's x plus 1 equals 0, x minus 3 is equal to 0, x minus 7 is equal to 0. I now have all my factors. So the first thing I'm going to do is FOIL x plus 1 times x minus 3. I'm going to get the x minus 7 in a minute. This gives me x squared, then x times minus 3 is negative 3, plus 1 means it's minus 2x. 1 times negative 3 is minus 3. Now I have to multiply that trinomial times my x minus 7. Lots of ways you can do this. One way is to make kind of like a little table here. Actually, I don't really have that much room, so we're going to do this. I'm going to do this guy. Give myself some space. And we're just going to fill it like this. So now, give myself back a pen. I'm going to put x minus 7 here, and then x squared minus 2x minus 3. X squared times x is x cubed. X squared times minus 7 is minus 7x. Negative 2x times x is minus 2x squared. Whoops, I forgot my squared there. Negative 2x times negative 7 is positive 14x. Negative 3 times x is minus 3x. Negative 3 times negative 7 is 21. Now I'm going to go through and I'm going to combine my like terms, which appear on the diagonals here. So my final answer here is x cubed. Negative 2 minus 7 is minus 9. X squared. Negative 3 plus 14 is plus 11x. And then I have the plus 21. That's it. That is in standard form. Largest exponent to smallest exponent. Good job. Okay, the next one. I'm going to erase this guy. And I'm just going to move this guy down a little bit. Okay, write a polynomial in standard form, not factored form. But now I have this guy, and he's going to be x equals 3 and x equals 2. So I've got x minus 3 and I equals 0. X minus 2 is equal to 0. But 2 is a multiplicity of 2, which means that I have x minus 2 quantity squared. This one happens twice. So when I FOIL that, I'm going to get x squared minus 4x plus 4. So now I can multiply the x minus 3 times my x squared minus 4x plus 4. So I have x cubed minus 3x squared. Negative 4x times x is minus 4x squared. Negative 4 times negative 3 is positive 12x. 4 times x is 4x. 4 times negative 3 is minus 12. Again, find those like terms. They'll be on the diagonals. And you have x cubed. Minus 4 minus 3 is minus 7. X squared. 4 plus 12 plus 16x. And then we still have our minus 12. Careful when you circle things, you don't lose those signs. Okay? So that's standard form. Now we want factored form for these last two. If you need to, you can go back and you can take a look at those guys. I'm going to get rid of my little board there. Come down here. Write a polynomial in factored form. This is easy. If it says factored form, don't make it hard on yourself. Okay? X equals negative 1. x equals 15, x equals 27 twice. It says multiplicity of 2. So this becomes x plus 1 is equal to 0, x minus 15 is equal to 0, x minus 27 equals 0, x minus 27 is equal to 0. When I write it over here, it's x plus 1 times x minus 15 times x minus 27 quantity squared. That multiplicity of 2 is right there. Great. Let's do this last one. 9 is a multiplicity of 2. So I have x equals 9 and x equals 9. Then I have negative 21, multiplicity of 3. So x equals negative 21, x equals negative 21, x equals negative 21. That means I'm going to have x minus 9, that happens twice, and then I have x plus 21, and that happened 3 times. Okay, sorry about that. So we have x minus 9, multiplicity of 2, x plus 21, multiplicity of 3, and you are done. That's objective 1 and objective 2 of the polynomials. Great job!